So, welcome back, I guess. Thank you for coming again. Today we'll be looking at the second question of the today's fidelity round. Uh, let's look at the question here. We are given a string of integers and underscores. A string contains both integers and underscores. The underscore can be filled with digits ranging from 0 to 9. The integer so formed must be a perfect square. When you keep on filling digits in the underscores, you get a particular number, right? String you convert into a number, and that number should be a perfect square. And we need to return the maximum value of the perfect square integer so formed. Like out of the n number of perfect squares you might get, you just return the maximum of them. So we have got an example here: 1 underscore 0 underscore 5, and the answer for this is actually 11025. The square of which is 105. One more side note to remember here is that the size of the string is always lesser than 13. So this is for like the input size is very small. So the brute force solution is actually accepted in this case. So we have got two solutions for this: the brute solution and the optimal solution. The brute solution is exponential and has a greater time complexity, and the optimal solution is much better. I will explain you both the concepts, and I will clearly say how to improve our intuition from the brute force method to the optimal method. So our let's start with the first intuition. Okay, the intuition will be that we have got underscores, right? We need to fill some digits in this underscore. What digits will you fill? We need the maximum integer. So for getting the maximum integer, you need to start filling from the descending order. You need to fill in 9 first, 8 first, then 7, and so on. And one more thing that will come to your mind is obviously, like, if the changes in the 10th place is very less significant than the changes in the 1000th place. So what you see from left to right, you when we are looking at all the chances, all of integers so formed, we keep the leftmost value as high as possible so that the number remains as high as possible while decrementing the rightmost underscore, so that you are traversing a sorted order. Like, you just keep on decreasing without jumping some solutions, possible solutions. So we we find that we have to put some digits in the underscore, then we remember it, we need the maximum, and then we start from ninth place. Similarly, 10 possible values can fill this underscore, 10 possible values can fill this underscore, which means there are a lot of permutations to look into. So the basic brute force idea that comes to our mind is to go through each and every permutation and check if that particular permutation is a perfect square or not. If it is a perfect square, and that perfect square so obtained is, it will always be greater, right? Because we are checking in the decreasing order. We are fixing the leftmost as high as possible and decrementing the rightmost. The perfect square, the first perfect square you will encounter, will always be the highest perfect square. You just return the value. So that's what I have done here. You fix 9 on the leftmost side, and then you keep decrementing the rightmost underscore. Similarly, you fix 8 and then decrement the rightmost underscore, and so on. The first time you come across a perfect square will be 11025, and this will obviously be the highest perfect square. And we have to check if it is a perfect square. If yes, we just return the value because it is obviously the higher. So, do you see the problem, guys, in this? Do you see the problem? Because in this problem, we're checking each and every possibility, each and every possible permutation, which means greater the number of underscores, greater the number of permutations, greater the number of for loops and everything. So what we are doing is, for each and every underscore, we are nesting a for loop. We are fixing this bit and decrementing this. Similarly, we are fixing this and decrementing these two if there are 3 underscores, which means the time complexity for this will be in the order of 9 power n, 10 power n actually. Tempo rendana. So when we look at this first approach, the time complexity will be exponential, because we will be looking at a time complexity of approximately 10 power n, because we are checking all possibility where n is the number of underscores in the given string. So we keep on nesting the for loops, and this is not optimal. But in this question, the constraint is very low. The constraint is just 13, the size of the string. So this will be accepted. But let us go a little bit further and discuss the optimal approach. So the optimal approach, let's just discuss the intuition here. What we are looking at is that we are checking for every permutation if it is a perfect square, right? So what do you infer from this is that we need only the perfect squares. We only need integers that are perfect squares. Then why are we checking other numbers? Let's just stick with perfect squares. So that's the intuition. That's how you move from the brute force to the optimal solution. So let's just stick with the idea that you just need perfect squares. Okay. So you have to, like, for a given integer, like with underscores, you have to check all the possible perfect squares in the range. Which range? You ask yourself, which range? You have to form the lowest possible number from the given input and the highest possible number from the given input. And you take the nearest perfect square for this, the nearest perfect square for the highest end, and then you loop over all the perfect squares. Why do I call this more optimal? Because the number of perfect squares does not depend upon the number of underscores, it depends upon the input size. And given there is a large number of underscores, the number of test case, the size of the for loop will remain the same. And the size of the for loop is much smaller because like the perfect squares, like, keep on the value between the jumps is very high. So that's the intuition 2 here we are talking about. We only need the perfect squares. And what I have done here is, you start traversing from the left side of the given string. The moment you keep traversing, the moment you hit the first underscore, you stop it and then you record it in a separate string. So here I have recorded 1 in a separate string. I was moving from here. I have moving 1 and then I hit an underscore. I recorded 1 in a separate string. So the least possible number for this given input would be that the recorded string plus every integer of every element after that is 0. That's what I have taken here. Lowest possible number will be 10000, and similarly the highest will be 19999. So we have got a range here. We have fixed ourselves a range. We just now check for the square root of it. This is how I have checked the square root of it. You convert this string, 10,000 is a string, right, to an integer and find the square root of it. You will obviously not get a perfect square, but since you typecast it to int, you will end up getting a decimal number. And similarly for high. And now we have got a perfect range with us. We have got the lowest possible perfect square. We have got the highest possible perfect square, which means you have got ourselves a range within which the answer absolutely lies. So no need to check all the possible permutation. You just check the range of possible answers where each number is a perfect square. So you just loop over from the lowest possible perfect square to the highest possible perfect square. And then one of the perfect squares will be 11025. And for this, like for every perfect square you come across, you just compare it with the regular string, the actual input we have got. We just have to make sure that all the characters apart from the underscores are similar, or same to same, index by index, same to same. So when, like, for in this case we have got 1 is 1, 0 and 0, 5 and 5, they're all the same position, the same index. Only the underscores, we don't see the underscores. So we know that this matches the input variation given and is also a perfect square. So we append it to a list. Similarly, when this for loop completes, we have a list of all possible answers where, like, each answer satisfies the given input condition is also a perfect square. We just return the maximum value in the array or list or vector or whatever we can use. So this is it, guys. To start with, we have just nested all the for loops and got all the possible permutations, check them if they were a perfect square. If yes, we return the value directly because we were obviously traversing from the descending in the descending order, and this is actually the has a higher time complexity, and it also works in this case. But the second method is more optimal, and in this case we just traverse over all the possible perfect squares, and then we check if that perfect square satisfies the given input template, and if it satisfies, we append them to a list and we just return the maximum value of the list.